4.1c is on solving systems of equations by elimination. So we've already solved using graphing and substitution. So today we're going to talk about this third method, elimination. So elimination kind of sounds like eliminate, right? So when you are solving using elimination, something should be eliminated, right? Something should be eliminated, which means it should disappear, it should cancel out, it should be gone as you are solving this. So for elimination, what do we need? Couple of things. We need to line up like terms. So looking at our example, notice that when we have 3x plus 7x, well, our x's are lined up. And when we have plus 4y minus 9y, our y's are lined up. And then we have our equal signs lined up. And then on the other side, we've got just whole numbers. Okay, so they don't need to be in that order, but your x's need to be lined up. Right, lined up from top to bottom. Your y's need to be in that same line, that same vertical line. Your equal signs need to be in that same vertical line, and your whole numbers need to be in that same vertical line. Looking at our non-example, notice how our x's are lined up, but our equal signs are not lined up, which means that our y's are kind of off, and then our whole numbers are kind of off. All right, so this is not good. This is a non-example. In order to solve by elimination, you have to line things up. The next thing you need is a pair of opposites. So you need a pair of opposites because opposites eliminate. So if you have 3x and negative 3x, those are opposite because they have a sum of 0. So that's what happens in elimination. You have something, a positive of something, and a negative of the same thing, and then they cancel out or they eliminate to 0. And that's what we want to happen. If there aren't opposites in the given problem, we will be able to make them opposite by using multiplication. Okay, so we'll use multiplication to create or make opposites and equivalent expressions if we need to. So equivalent equations, looking at 2x plus 2y equals 5 and 4x plus 4y equals 10. Take a minute and think about how are the above equations related. Okay. Well, we were just talking about the fact that if we need to, we can use multiplication to create equivalent expressions. So looking at these expressions, hopefully you noticed that this bottom expression is just the top expression, 2y plus 2y equals 5, multiplied by 2. If we were to multiply this by 2, well, that would mean we get our 4x, we'd get our 4y, and we'd get our 10. So that's what we're talking about when we're saying we can multiply to create equivalent expressions. So these are actually equivalent equations. These are equivalent equations. It's just, right, 1 we multiplied by 2. So when we're solving by elimination, we can use that multiplication to make opposites if there aren't any. Now that we have the groundwork, let's actually try a couple. So we want to solve these systems by elimination. So keep in mind something should be eliminated. Looking at our problem, notice that our 5x and 3x are lined up, our negative 6y and 6y are lined up, our equal sign is lined up, and our negative 32 and 48 is lined up. That's what we need. So since everything's lined up, the next thing we need to look for is our pair of opposites. We'll notice right here we've got a negative 6y and we've got a positive 6y. So since we've got that pair of opposites, here's what we are going to do. To solve by elimination, you just take your expressions, you have them lined up with your opposites, and then you combine them. So we are going to add these expressions together. Okay, we are going to add these expressions together. So we're just going to add them in that vertical line. So 5x plus 3x would give us 8x. Negative 6y plus 6y is 0, right? So these eliminate. These are gone. That's where the elimination method comes from. We have our equal sign, and then negative 32 plus 48 is going to be a positive 16. Well, 8x plus 0 is just 8x equals 16. Notice that now, since we only have that one variable x, we are going to be able to solve for x. So we'll divide by 8 on both sides, and x equals 2. Now that we know what x equals, we can take that value and we can plug it into either of these original equations to find y. So it doesn't really matter, so I'll just pick this bottom one. So instead of 3 times x, we'll have 3 times 2 plus 6y equals 48. Well, 3 times 2 is 6, plus 6y equals 48. and then we just solve using our inverse operations. When 6y equals 42, we can divide 6 on both sides to get y equals 7. So our one solution for this is x is 2 and y is 7. So our one solution would be the ordered pair 2, 7. So this is our elimination. We lined up all of our terms. We made sure we had something that would eliminate. We added them together, and that's when it did eliminate. And then since there's only that one variable left over, that is how we are able to solve these equations. Let's look at a couple more examples. 8x plus 5y equals 6, and 3x plus 2y equals 10. So notice that they're lined up, but we don't have a pair of opposites. So since we don't have a pair of opposites, we need to pick something to make opposite. Okay, so we could pick our 8x and our 3x, or we could pick our 5y and our negative 2y. Well, I'm going to pick 5y and negative 2y because one's already positive and one's negative, so I just need to make them the same number. Well, 5 and 2 both go into 10. So in order to make this 5 into a 10, I'm going to multiply everything by 2. In order to make this negative 2 into a negative 10, I'm going to multiply everything by 5. So the other thing with elimination is that when you're using multiplication to make equivalent expressions, you're not just multiplying one number, you have to multiply everything. If you don't multiply everything, it's not an equivalent expression. So if we go back up here for a second, if we had just multiplied 2x by 2, well, 4x plus 2y equals 5 is not equivalent to 4x plus 4y equals 10. Okay? So it's very important to remember that you have to multiply everything. All right? Everything. So we'll have 8x times 2 is 16x, 5y times 2 is positive 10y, and 6 times 2 is 12. So then we have 3x times 5 is 15x, negative 2y times 5 is negative 10y, and 10 times 5 is 50. So now we have everything is lined up and we have a pair of opposites. So we just need to combine our expressions. 15x plus 16x is 31x, 10y minus 10y is 0, and 12 plus 50 is 62. And our y's eliminated, which is what we wanted to happen. If nothing eliminates, you need to go back and you need to figure out what you did wrong. 31x plus 0 is just 31x is equal to 62. Divide by 31 on both sides. X is equal to 2. So we have our one solution, but we need to find our y value. So again, we can plug it into either of these equations. It does not matter which one. So instead of 3 times x, I'm going to have 3 times 2. Minus 2y equals 10. Well, 3 times 2 is 6, minus 2y equals 10. And again, from here, we are just using those inverse operations to solve. Divide by negative 2 on both sides, y equals negative 2. So our one solution would be 2, negative 2. And this is how we solve by elimination. So now would be a good time to pause and see how far you can get. We're going to do a couple more examples. So looking at letter C, again, everything's lined up, which is great, but we don't have a pair of opposites, so we need to make a pair of opposites. Well, I'm going to, since this bottom one is 4x and is a 4x, I know that I can multiply 2x by a negative 2 in order to make a negative 4x, right? So I pick either my x's or my y's, and I ask myself, well, what could I multiply to make that pair of opposites? So I picked my x's, and I said, well, I could multiply by a negative 2. Well, 2x times negative 2 is negative 4x. Negative 3y times negative 2 is a positive 6y, and 9 times a negative 2 is negative 18. And then that bottom equation gets to stay the same because notice we have a positive 4x, negative 6y, and 5. So we have our negative 4x and our positive 4x. Okay, so for this one, all we needed to do was multiply the top equation by something. Sometimes you'll need to multiply both. Sometimes you'll just need to multiply one. But whenever you have everything lined up and you have a pair of opposites, that's when you can start combining them. So that's what you need to look for, just one pair of opposites. Negative 4x plus 4x is 0. 6y minus 6y is also 0. And negative 18 plus 5 is negative 13. Well, we have 0 equals negative 13. That is not true, and anytime we get something that's not true that tells us we have no solution. So this is what no solutions would look like when we are solving by elimination. One last example. So again, it'd be a good idea to pause and try it out if you haven't yet. We've got 4x plus 5y equals 12, and 12x plus 15y equals 36. Well, I could pick either my x's or my y's. It does not matter. I'm going to pick my y's. Looking at 5y and 15y, well, I could multiply 5 by a negative 3, and that would make it negative, and then 5 times 3 would be 15. So that's what I'm going to do. 4x times negative 3 is negative 12x. 5y times negative 3 is negative 15y. 12 times negative 3 is negative 36. And that bottom equation, again, that one just gets to stay the same. I don't need to change it because just by multiplying the top one, I was able to make that pair of opposites. Then we can combine them. Well, negative 12x plus 12x is 0. Negative 15y plus 15y is 0. Negative 36 plus 36 is 0. So we get 0 equals 0. Well, that's always going to be true. So since that's always going to be true and all of our variables eliminated, we have infinite solutions. Infinite solutions. So that would be our answer. And this is solving by elimination. So again, make sure everything lines up. Then you need that pair of opposites. And then last but not least, you add the two equations together and solve.